Have you wondered why matrix multiplication is defined the way as it is? Take, for example, 2 by 2 matrix multiplication. For example, this element, right, in this result matrix, its position is row 1, column 1. And what you do is you take the first column of the first matrix, multiply it by the first column, first row of the first matrix, multiply the first column of the second matrix, corresponding elements multiply together, and then you add them up. Well, here is some motivation of why it is defined the way it is. So first, let's look at this graph, x, y, and we have this point P1, x1, y1. We rotate it by beta degrees, in radius. So here's alpha, there's beta. And of course, the radius does not change. Let's say the radius is just 1. So rotate it all the way to P2. You have x coordinate, y coordinate, x2, y2. And we say the length of P1 is equal to the length of P2. Like the OP1, OP2 vector length is just 1. Now, the x coordinate of P1, right? x1, of course, is cosine alpha, right? And y1 is, of course, sine alpha. Okay? And then we have the coordinate of x2. Right? x2 is cosine alpha plus beta. You have y2 sine alpha plus beta. Right? There is angle sum. Cosine alpha, cosine beta, minus sine alpha, sine beta. And there is sine alpha, cosine beta, plus cosine alpha, sine beta. Right? There's the, so again, so we have x2, y2. x2 is equal to, remember, cosine alpha is x1, right? So that is x1 times cosine beta, right? Sine alpha is actually y1. So minus y1 sine beta. Right? So y2, sine alpha, cosine beta. Sine alpha is y1. Right? Sine alpha, cosine. Let's write cosine alpha, sine beta. Right? Cosine alpha is x1. x1 times sine beta. So it's consistent, right? x1. And we have sine alpha, cosine beta. Sine alpha, y1. So y1 cosine beta. Right, this time. So let's now just focus on the coefficient of xy, right? Coefficient cosine beta, sine beta, sine beta, cosine beta, right? So coefficients, let's put it in a table, right? Called a matrix. Cosine beta minus sine beta and sine beta and cosine beta. Right? And let's call it matrix A. Right? Likewise, if we rotate it by theta degree, right? By theta degree, maybe up to here, theta degree, then likewise we can call matrix B, right? Cosine theta negative sine theta, cosine theta. So we just focus on the coefficients of xy, right? The cosine, sine, negative sine, cosine. And if it's rotated by theta degrees, right, we just say cosine theta, negative sine theta, cosine theta. Call it a rotation matrix. So if we want to rotate rotate beta plus theta degrees. All right, how about beta plus theta degrees? So obviously we can follow the same pattern and write cosine beta plus theta and negative sine beta plus theta. Right, and next entry is sine beta plus theta and cosine beta plus theta. Right? Actually, let's expand everything out. Right, angle sum. Right, cosine beta cosine theta minus sine beta sine theta. Right, that's the first entry. Right, this entry is negative sine beta cosine theta negative cosine beta sine theta. Right, and next entry sine beta cosine theta plus cosine beta sine theta. Right, this one cosine beta cosine theta minus sine beta sine theta. Okay, so by definition, A times B. Right, so here we go. So A times B is equal to, according to definition, right? First row times first column, corresponding elements multiply together and add them up. So cosine beta cosine theta minus sine beta sine theta. Cosine beta cosine theta minus sine beta sine theta. Right, first entry. Second entry. Right, first row multiplied by second column. Right, negative cosine beta sine theta. And this times this, negative sine beta cosine theta. That's my second entry. This entry, right? Second row times first column, right? Cosine, sine beta cosine theta. Times cosine beta sine theta. Cosine beta sine theta, right? Second row, second column. Second row, second column. Negative sine beta sine theta. And this times that cosine beta cosine theta, right? Plus cosine beta cosine theta. Now, are they the same, right? This is the result by multiplication by definition, and this is the result by rotation matrix, right? We call it more rotation matrix, right? If we rotate beta degree, we have this matrix. If we rotate by theta degrees, we have this matrix. And if we rotate by beta plus theta degrees, we have this matrix, right? This is what I use angle sum, angle difference, right? Expanded out to this matrix. Now, do they look the same? Cosine beta cosine theta minus sine beta sine theta, right? First entry. Second entry, negative sine beta cosine theta, right? Negative sine beta cosine theta. Negative cosine beta sine theta, yes. Sine beta sine theta plus cosine beta sine theta. Right, this entry, cosine theta, cosine beta cosine theta, cosine beta cosine theta, negative sine beta sine theta. Now it all makes sense. Now if we take matrix A multiplied by another vector, column vector, another special matrix, so A multiplied by a column matrix. Let's call it x1, y1. Right? So it has 2 rows, 1 column, right? 2 by 1. So this multiplied by that. And that is equal to, right? So according to the definition, right, we have first row times first row times first column. Right? Only have 1 column, right? First row. So x1 times cosine beta and minus y1 times sine beta. Right. Since A is 2 by 2, right? This column vector is just 2 by 1. So multiply out, we should have a matrix that's 2 by 1. Right? 2 rows, 1 column. Right? So the first entry. Second entry, take the second row multiply by this column. Right? So x1 times sine beta. y1 times cosine beta. Right? So this is exactly the coordinates of x2, y2. Right? That is coordinates of P2, this point. Right? So what this matrix does, right? So what matrix does, the rotation matrix, is that it rotates a given point to another point, right? Of course, the radius remains the same, right? Rotation according to the origin, right? That's what this matrix does, right? It makes perfect sense.